Okay, hello everyone. My name is Bob Cohen, and I am an adjunct professor at Seton Hall. I teach in the cybersecurity certificate program, and one of the programs I teach is Informatics, and I also teach IT project management for the Stillman School of Business. But I will be taking us through this Python workshop today, and we do have an open chat, so if you have questions or comments, please put them in the chat, and I'm happy to interact with you as we go through this workshop. So with that said, I'm going to try and make this workshop as hands-on as possible, and I have a number of different things to show you and to interact with as well, but a few slides to start out with. So we will cover this agenda, talk a little bit about why should a cybersecurity person even learn to code? What is informatics? What do we mean by that? We'll talk about a couple of different software tools in the Python development space. And then we will go through a hands-on scenario where we're trying to analyze data for a cybersecurity issue. And finally, we'll end it with talking about where do we go next if we're interested in some of what we see here. So with that, talk a little bit about the background and why do we study Python or any programming language for that matter. And I do want to mention that this workshop is really meant to be open to anyone, whether they know a little Python or not, whether they've studied programming or not. So this isn't necessarily the place where we're going to go deep into Python. We really can't in an hour, but we're going to see some examples of it, and we're going to hopefully learn a little bit of the basics that will allow us to move forward. We'll talk about how hard it is to be a software engineer and what that really means in the real world. We will cover a number of different things here. So and in fact, maybe the analogy that I'll give is we think about how hard is it to be a software developer or a cybersecurity software developer in the real world. And the analogy that comes to my mind is a little bit of how hard is it to learn to play the piano? Okay, so the analogy really is that if you want to really just learn the basics and write toy applications, learning Python is pretty easy. And in a similar way, if you want to really learn how to play a simple tune, let's say Mary Had a Little Lamb with one hand on the piano, that's pretty easy. Similar analogy. But becoming a professional software programmer and having the ability to build robust real-world applications is actually fairly hard, and it takes years of work. Just as becoming a professional pianist takes years of work and dedication and practice. So with that as the analogy, we are going to talk a little bit about what informatics is. And you can see the bullet on the screen really kind of talks about using the principles of information science or information technology to solve problems using data. So this tends to mean that it involves the practice of information processing and engineering of information systems. It considers the interaction between humans and information alongside of things like the construction of interfaces, the interactions of organizations, technologies, and systems. So there's a lot that is encompassed here. And in fact, the various academic disciplines that are encompassed include things like computer science, information systems, statistics, information technology, and various other academic disciplines. So basically, what we're looking at is with the advent of computers proliferating and being available to almost anyone, individuals and organizations are increasingly processing information digitally. And that's really led to the study of informatics. And really what we're talking about with informatics is a lot of different areas that include computational areas, mathematical areas, biological, cognitive, social aspects, various different aspects of technology as we kind of discuss informatics and what we might use Python for as part of the informatics discipline itself. So it's a pretty broad category. With that, what I will now do, and actually just want to take a quick check. For any of you supporting this now, are you hearing me and able to see the screen? Michael or Lisa?
It looks good. Yes, absolutely. I've got your
great,
screen.
thanks.
You could make your slides go full screen if you want, but I know you're going to bounce around, so I wouldn't.
Yeah,
worry.
that's the only reason I'm not going to do that. But thank you. Just want to make sure that people are with me.
Absolutely. Looks great. Sounds great.
Very good. So we're going to now go from what is informatics and this big field of study to really focusing in on Python as a language and get a little bit hands-on with the developer tools that are used in Python. And I'm going to go through some tools here. There's 6 tools. We're going to talk about each one specifically, and then I'm going to put up a diagram that kind of shows them in context, and then we're going to go through them. So you will actually be seeing what we do with them, and in the case of one, interacting with it yourself specifically. So Python interpreter is just that. It's really Python itself. It is the program that takes the language or the code or the source code. They all mean the same things, and it's the thing that converts it to machine language and runs it on a device. Python is available at python.org. We are not going to actually go through the install process in this presentation, but it is quite easy to go at yourself, choose the appropriate operating system, make sure that Python is installed and included in your operating system path, and it is a relatively simple and painless installation in order to use Python locally on your device. In addition to that, a lot of people use a code editor to write your software called Atom. Atom, I believe you can download at atom.io. But again, we're not going to actually go through the installation of it. You are going to see these products specifically as we go through this presentation. We're also going to talk about notebooks, which is it's a method for you to store documentation and Python code and get the results of that code all in one place, in one document, if you will. And these notebooks are able to be placed and managed and used on the cloud, which is another important aspect of it. Finally, we're also going to talk about source management, and the tool that we're going to discuss for source management is Github. Github is not specific to Python, but stores software or code and or other files for really any language or any project that you have that you want to store appropriately and have backups of. And then the tool that you all are going to be able to use to look at a notebook is a tool called Binder, and we will demonstrate that as we get through this workshop. Finally, the last tool that I'll just mention is the interactive development environment, which comes as a part of Python when you download and install it. We're not going to talk too much about it, but I am going to show it to you as we go through this discussion. So with that said, those are the development tools that we're going to be discussing. And this diagram now is an attempt to put into context a little bit of the logical flow and usage of all these software tools. So the thing that I would ask you to do is look up at this top row and just consider these three boxes for a minute, this top row, because this is the main workflow that is typically done with Python in the real world by professional programmers. And these three boxes consist of editing your source code in Atom, then they consist of running the Python interpreter, and then viewing your results. And these last two boxes are typically done in an operating system terminal or command box or environment such as that. So the first thing that I'm going to do is actually bring up an instance of Atom, our source code editor. And you can see, so I'm now running Atom on my desktop. I have a program here called example1.txt, and I have a project which lists all my files in this project on the left. And what I really have here is some Python code, but it all looks just like text, okay? There's not a lot here that jumps out at you. It looks very plain. There's something called my_var, which from a text perspective, Atom almost looks at it and says, "Are you sure you typed this right? It doesn't look like any word I've ever seen before." But Atom right now does not know that this is a Python project, Python source file. And what I am going to do is save this file as python.py. Because I already have it here, it's going to say, do I want to replace it? Yes, I do. But you'll notice when I save it as a Python file, all of a sudden I have things scripted very nicely here. Reserved Python words are in blue. String constant text are in green. Numbers are in orange. It now knows that my var is really a variable that I'm using in Python. So here I have about 4 Python commands that are just very basic commands in the Python language. And without knowing any Python, or well, first of all, if you do know Python, you know what this obviously is doing, which is printing 2 lines of text, creating a variable and assigning a number to it, then printing this text saying here's my new variable, with the method that takes that variable and puts it in the string text as well. So in Atom, I've just created a source file. I've put this code in it. I've saved it, which is a very important step. And once I have it saved, I'm going to go to my command dialog box. And first thing that I'm going to do is a directory and make sure that I have the example1.py file in this directory. I am then going to call the Python interpreter with example1.py, and Python is going to interpret that source code and send the results directly to my screen. So you can see from the results here that Python ran that code and sent the results to my screen. And so what I've just attempted to demonstrate is these 3 boxes of how these software tools integrate together and work together. Okay. As an alternative approach to working in this environment, you could use the Python interactive development environment, or the IDLE. This is typically an OR. It's not, I use one sometimes and another sometimes. Typically, this 3-box method with Atom and command boxes is typically the way in the professional industry organizations Python is run. But in an interactive environment, a lot of times it's for specifically interactive work. So if I'm an analyst and I just want to get in and look at data or interact with Python, it's quite possible to do that. And I'm going to bring that tool up right now. So here I'm in the Python interactive environment, and I can do things like just say, 44 plus 9, what is it? I can say print. This is a test. The IDLE environment will run it. So here, I'm doing very simple, trivial, toyish like type things, but I can also run large programs from this environment. I can save them, I can run them, I can debug them. So this is an environment that will be used, often in an interactive manner to dig down in data or do some things that you just prefer to do in the interactive environment. If you're using that interactive environment, you typically then will not be using the more professional environment that I've mentioned with these 3 boxes to the left here. So now let's get down to the lower portion of this diagram, which really talks about the idea of notebooks. Notebooks being both Python code and documentation that can run in a given environment. And so you will see what a notebook is in a little while, but for now, if you just accept it as Python code and Python documentation, I think what's more important to note is that either source code that you store in Atom or any other text editor, or notebooks that you store in any place locally on your device, either of those can be loaded into our source management system. And in this case, the tool that we're going to use for our source management system is GitHub. Now, I'm going to bring up our source management system. So this right now is a view of GitHub for a public directory that I have stored in the cloud on GitHub. So you can see that it's got my username and then this rest of the URL. And when I created it, I made it public, and I've loaded these various files into it. And I've also copied a launch binder button from my binder site as well. So I'm talking about a lot of things all at once here. But essentially right now, I'm in GitHub. I've added these files to GitHub, and these are in a public source management system. So what happens in a source management system? Why do we use it, and why is it important? Well, one thing that we use it for is backup and safety and management, so that these are now on these files that I have in this directory are they're saved, they're automatically backed up, they're recoverable if the issue happens with them. And what I can also do is something called branching, which allows me to keep a version and start another version of my programs where I can enhance it or create something different, but I still have the prior version that I can go back to if I need to or want to for any reason. So I'm gonna try to orient you as to where we are. We're looking at this GitHub source management platform. I've made it public, and the other thing that is a huge help to me in terms of source management is I've actually now have a way that I can distribute this to all of you attending this conference right now, or I have a method for distributing this to anyone I want, but either giving them access to it or making the repository public, in which case anyone can have access to it. So in my particular case, what I've done is I've taken Python code and I've taken notebooks and I've stored them on GitHub. And I've also taken a binder container that can run, in our case, we're going to run some notebooks. And I've taken the launch button for this binder container and put it in my GitHub source management as well. So now if you're following along with me, here's where you get to what will hopefully be a hands-on component of what we're doing here. So I would ask that, well, the first thing that I'll do is let me bring up the URL that I'd like you all to be able to use.
I went ahead and put that in the chat for you, so that's all
Oh,
set.
excellent. Thanks. You're way ahead of me. Perfect.
Yeah, I figured I'd be useful. There is a question that's popped in. It's kind of a little bit of a higher level question outside of where you're going, so I can hold it till the end, or if you want to think about it now while people jump to the website.
Sure, that would be good.
Okay, so the question is, in terms of cybersecurity analysis, how can Python be utilized with industrial tools like Splunk or QRadar to enhance security analysis? Like I said, it's a little bit of a higher level question.
Sure.
But it is a little more, it's certainly in line with the themes of the conference today.
Sure. So I will answer that very quickly, and then I'll come back to it kind of towards the end of the session as well. But just at a very quick high level, what I will say is that a lot of times Splunk and some of these other products are really great products, but they're very oriented to the tasks that they deliver for. And what Python allows you to do is further customize any output coming out of Splunk or any other tool. It allows you to interact with data format, set it up so that it can be read by some of the cybersecurity tools. Essentially, what Python allows you to do with other cybersecurity tools is customize your interaction with those tools, whether it be with data coming in or more advanced reporting coming out. So I'm going to leave the answer as that for now, and I'll come back to it later when we get towards the end of this this discussion as well. But my hope at this point is that everyone is at this GitHub site, and what I would like you to do is everyone launch the Binder site, and you can see when I'm doing that, it brings up a Binder flash page and starts the repository just for me. This can take a while, so I ask you to kind of be be a little patient, but hopefully this is working for people. And this is what you're looking to get on your screen if you have been able to do this. Michael, can I ask for a hands up of people who have been able to launch Binder successfully and get this output on your screen?
Yeah, certainly. If you've been able to launch Binder successfully, go ahead and just say yes or no in the chat, and we'll keep an eye on that for right now. We don't have a thumbs up, thumbs down to measure from the audience, but certainly they can all message in the chat that they're getting there.
Okay, that's great.
Yeah, there are certainly people that are getting there.
I'm sorry, just for me, has someone said yes, they've got it?
I've got 4 yeses in about 10 seconds.
Perfect.
So
okay.
People are coming on with it.
Okay. So I'm going to hope that you all got it. If you did not, you're still welcome to just continue to view my screen. While you're viewing my screen, you're not going to necessarily do anything differently if you've been able to bring it up yourself. Other than you can try it yourself, you can run things, you can change the code, you can modify things, so you can start to kind of play around with it a little bit. But assuming you've gotten this screen up here, what you want to do is launch this first notebook. It says cybersecurity, and then it's truncated, it's cut off, but it's just this first notebook. You want to double click on it. Okay. And if you have it up, you are now in a notebook, okay? And what we're going to do is we're going to run through a little bit of a scenario, a cybersecurity investigation. So again, I'm going to assume that there's no prior knowledge of Python, and I'm going to walk through the code that you will see interspersed in this documentation. I'm going to walk through it at a very, very detailed level to try and explain every statement of code that you see. But before we get there, let's start with what's the problem? What's happening here? And I'm going to read these 3 topics. You've just obtained a job working as a cybersecurity analyst for ABC Corporation. The company has over 5,000 employees, and they sometimes find a specific staff member is an internal threat to the security of the firm. The Corporate Investigations Department has asked you to review the email log file, the inbox log file of an employee who may be receiving emails from users and internet domains that have nothing to do with their current job position and job responsibilities, and something about either this person and or what they've heard has pointed them in the direction of trying to investigate this person a little bit further with the data that they've done in their email. The email log file is very large, and the investigations department cannot scan through it manually, and you're asked to find a way to review this data and pull out all the email addresses that the employee has had contact with. So let me just stop there for a minute, because that's the full scope of the investigation scenario that we're going to do. If you have any questions about what it is that we're trying to accomplish here, please feel free to ask those questions in the chat. And I'll just ask, is anything coming through in the chat where people are questioning this?
Nothing specific to what you're doing right now, but there was a question right at the start asking why most of the scripts for recon are made in Python.
Yeah, so, okay. So I believe the answer to that is many, not just recon, but many scripts in many professional products are now made in Python. You know, and there are a lot of reasons for that. But most of the reasons have to do with the easy availability of Python, the ability to run it on any environment, Linux, Windows, Mac. Really, interoperability is very solid. Reliability is very solid. There is a large contingent of software developers that know Python well and are available when products are being built. So for many reasons, Python ends up being used as the underlying component or underlying scripting that is done for recon as well as many other products as well.
There are quite a few people that are applauding your response at this point.
Okay. That's good to know.
I believe calling it the duct tape of the web.
Very good.
Would explain that to most people. So.
Yep. Okay. So we are now faced with this. We want to search through this email and try to figure out what's going on here. We're going to use something called regular expressions, which is a package that is available in Python, but regular expressions are a feature that is available in many, if not most, languages at this point. So if you learn R, or if you learn C, or if you learn other languages, real expressions are a common way to parse through data, especially unstructured data that is not easily, pulled apart by any other tool. If you looked at our email log file, in fact, let me just bring it up real quickly. I think I have it open. You know, this is what you're looking at. You're not looking at something that you could easily dump into Excel and it would fit nicely in Excel. We're looking at kind of parsing data, if you will. And regular expressions is extremely good for that. And Python is also extremely good for that. So again, to start from the very beginning, because we have some people on this session who have no knowledge of Python whatsoever. If I put a pound sign at the beginning of my line, it is a comment, meaning Python ignores it. But you can use it to put some documentation in it. So here I have documentation in my notebook saying search lines contain from. That's what I'm looking to do. I also have some comments that are included in my code itself. And one of the important comments that I just want to make is that the initial code and data for this example was taken from a website called Python for Everybody that's managed by Charles Severance. And his material is freely available for educational training. And you're welcome to visit that site to look at what is available when you have a minute. But more importantly, I'm going to go to the real lines of code that are doing something in this particular program. And the first thing that I'm going to do is bring in a package I'm going to bring in software that is available for me to use by importing it. And what I'm going to do is import a package called regular expressions, or really denoted as RE in the Python package library itself. That's the first statement of my program that is actually executed. The next statement of my program is I'm going to create a new variable called count, and I'm going to set it equal to 0. And then what I'm going to do is open up this email file that I want to do my analysis on. Now, opening an email file includes using the open command on a given file, in this case, a text file, and you have to give it that file name. And if the open command runs successfully, it assigns a data structure called a file handle to this new variable, f handle. This f handle is simply, again, a variable. It stores some of the data that it needs for me as a programmer or a software developer to be able to read what's in this email file. Okay. Another comment about what I've done here is I happen to know that my email log file is very large. So what I've done outside of this program is I cut and am using a much smaller sample of my data to run my program. And I'm going to verify that my program is correct and is accurately working. And then I am going to open the larger email file. But you can see what I've done here is I have a comment right now on the file I really want to use, and instead I'm opening the file that is a much smaller file. And if that statement works correct, I will have a file handle that allows me to read this data. Now, before I reference the idea of what does it take to be a professional programmer, and here's an example of where I'm doing something with no regard for the possible errors that could occur here on the open statement. So if I were really writing this code to make it be sustainable and manageable in a production operational environment, I would have a lot of error processing that goes on here to handle what happens if my open doesn't work, and what do I want the program to do, and how would I shut down gracefully or give the user an opportunity to add a different file name, a lot of things that I might do there. But none of that is included in this code right now. I simply open the file and get a file handle back, and then I have another comment statement, and finally I go into a loop or an iteration. And the loop I have highlighted on my screen here, and it is I'm really looping by using this for statement and a variable called line. So this is yet another variable. Okay, so if I count the variables that we've talked about in this program so far, we have a variable called count, we have a variable called file handle, we have another variable called line. And this for line in f handle is essentially saying read a line. And it will read a line and do the next set of lines until there are no more lines to read. And when I say it will read a line and do the next set of lines, what I'm really commenting on there is that Python uses indentation to determine the size of a loop or an iteration. So this loop starts with a for statement and the condition that it wants to do, which is to read lines until I reach the end. It has a colon at the end of it, and then it's indented. And everything here is indented, including some further indenting. But until I get back to the original indentation, which is underneath the for statement, I am in a loop. And I'm in that loop until my final condition is handled, and then I break out of the loop and I go to the next statement, which in this case is the print statement. So for each line in this file, what I'm going to do is I'm going to strip out the parts of the line that I do not want. Unnecessary spaces at the beginning or the end of the line, new line characters, things that I don't want. I'm going to use this rstrip function to pull out. And we haven't really talked about Python types yet, and this is probably a good time to bring it up in the conversation. So our count variable here is of type integer, and it stores an integer variable. Okay, our line is of type string. It's reading in text, and it's of type string. And the type string in Python is an object. And in fact, objects have methods or functions or code or software that can be run against the object. And the way to do that is with what we're calling dot notation. So you see line dot rstrip, and that's running the function method rstrip on the object line. And in fact, what I'm going to do is just bring up a whiteboard. Just ignore what's on the right whiteboard here for a second, and I'm gonna talk for just a brief minute about object-oriented coding, because that's what you're doing in Python, whether you realize it or not. And part of what I mean by that is that before object-oriented coding, there was the concept of sequential coding, and it was just one line after the next, after the next, after the next, and that's how code ran. But with object-oriented programming, what we really have are objects that we create. Okay, and those objects contain data, and they contain methods or functions. Each one contains data and methods. And let's say that we have an object that we define here. We have an object that we define as line, and its type is string. Well, that means that we know that we can use that line and use the dot notation to call any function. We were using rstrip, but we could use line dot capitalize, for example, or line dot concatenate, and the list goes on and on and on. So what we're really dealing with in Python is objects of various different types. And I'm going to take us back to the code now. What we see is we've called our line function and gotten rid of the miscellaneous characters that we don't want. And now we do an if statement where we do some conditional logic. And this conditional logic, or this if statement, is exactly that. It uses the word if, which is a Python reserved word. It then creates some kind of condition with a colon. And then, assuming the condition is true, it does everything in the code block indented underneath the if condition. So this is the second example of where Python indentation is very important. And what's happening here is we are using this library that we imported, real expressions, to use a method of real expressions called search. And search takes two input parameters. It takes what you're looking to search on and what data you're looking to search on it from. So we have our line of data. We're looking for the word from colon in it, and that's input to the search method of the regular expressions object. And if we, in fact, as we're going through our loop here, the first thing we're doing is taking out the miscellaneous characters. Then we are finding all the lines with from, and then we are printing those lines. If a line does have from, we're printing it and increasing our count. If the line does not have from, we are simply ignoring it and going back up to the next line in the file. So that is our loop, that is our string management, and that is our regular expression search on the data we're trying to find and determining whether we print it and add to the count or not. Finally, when we're completely done with the loop, we print out the final value of count to say how many from lines we actually found in our code. So with that said, I'm going to do this, and you can run it along with me if you've got it up on your device. Simply by hitting the run button here, I'm going to run the selected cell. And so for right now, I do not know why this is interacting with me. It may have timed out. So what I am going to do on my device is go to this locally on my device. And this is the same program. I'm going to run it here, and you can see the results. If you did not time out, I really am a bit shocked that that timed out in the amount of time I was talking. But you should see that I was able to see all these from emails, people corresponding with the person that we have in question. And in my small file, there was a count of 27 lines. Michael, can I just take a quick time check? Not time check, wrong word. Can I just take a quick check of success or not? Can we see if anyone in the attending has been able to execute the binder version of this on the cloud?
Sure. If anybody in the audience has been able to successfully execute it, just go ahead and hit yes in the chat, or if you have a question, we'll see if we can do a tiny bit of troubleshooting. I'm afraid we're going to run on time, though. We got at least one person who's definitely made it work.
Okay.
A couple more.
Good. I mean, that's all I really wanted to know. I mean, some people may not be able to get it to work for whatever reason. I mean, ideally, it really should work 100% of the time for 100% of the people, regardless of what browser they have or what device they're using. But obviously, we can't really debug it in this workshop. What I am going to do is go ahead, though, and make some changes to this. And if you have Binder running on your workstation successfully, you can make these same changes. So the first thing I'm going to do is comment out my small file. And now that I know my program works, I'm going to run it on my big file. So I am going to make that one simple change. I'm going to run it again. And now here you can see that I have not only hundreds, but thousands of lines of data. And I'm going to scroll all the way down to the bottom just to see that the number of emails that I was actually able to find in my log are using the word from as an indicator is 1,797. So almost 1,800 emails that are being sent. However, when I'm saying that, what I'm also doing is I'm looking at the output, and I'm just looking here that, hey, this makes obvious sense to me now that we have multiple emails from the same person, right? So this person, ZQIAN from the University of Michigan.edu, here's 1, 2, 3, 4, 5, 6, 7, 8, 9 times that they sent this person an email. You know, that in the cyber scenario that we've set up, that doesn't really faze me. But if I had seen 7 different emails or even one email from bad guy at hacking.net or something, you know, obviously I'm making up that particular email, but I would be able to scan through here and look at do these email destinations, you know, are they from people that make sense or do they make no sense at all? I'm going to continue on here with some of our examples because I'm going to try to leave a little bit of time for question and answer. So I'm going to pass right through this, but essentially what I've done here is show some more of the search method with regular expressions and an ability to do a little bit more than just search from. So here I've expanded my search to show from, and then the dot plus says search anything from the word from to inclusive of the @ sign. So I can really parse through this line with some very unique parses using very little, very simple indicators to the real expressions programs and capability there. I'm not going to run this because it'll really show the same result. And what I more wanted to get into is the point of getting the count of multiples of the same email address. And I'm going to do that using a simple Python dictionary. And I also want to step back and say that this at this point of the presentation, if you have had no Python experience or no programming experience whatsoever, this is where it gets somewhat more difficult to understand. So I'm going to go through it very carefully, but if you don't understand, at least you have the Binder worksite and the ability to bring that up, look at it, modify it yourself, analyze this code, run it against the samples here, and hopefully get it after working with it a little while if you don't get my explanation in complete sense here. So again, my goal is really to get this exact same output, but without the multiples, and to have a count of what those multiples are. So I'm in my program, and it starts out exactly the same as I was before, but I create this dictionary. And a dictionary is really, in Python, it's nothing more than a pair of keys and values. So just like I were looking something up in the dictionary, and I looked up the word in a dictionary and it had the definition next to it, I can look up a key in a particular dictionary and it will have the value of that key next to it. So with that being said, I create this empty dictionary. I open the same file. This is my small file. I go into this loop, processing the file, strip out miscellaneous characters. I do my regular expressions to only pull out the lines that I'm interested in. And when I find the lines that are interested in, I add them to the dictionary and I add 1 to the counter. Now what I do is, I'm sorry, I said I add them to the dictionary. I actually add them to this email address variable. Okay, so I add the email to this variable called email address, and I add up the counter to 1. And then now I use this if-else statement to, if the email address is not already in the dictionary, I add it and I set the counter to 1. If the email address is already in the dictionary, I add the counter to the dictionary. I add 1 to the counter of the value in that dictionary. And then finally, when I'm all done with that loop, I've ended my for statement, I've processed all the lines in the file, then I print my dictionary. And then after printing my dictionary, I will also print the total count that I found. So again, I am running this on my small text file. You can run this in Binder and it should work. You just have to scroll down and select the appropriate cell and run it. You can see that I've run it here. And what I get is a dictionary that says Stephen Marquard at UCT. He's in there twice. Lewis at media.berkeley.edu is in there 3 times, and so on and so forth. And the total number of emails that I have is 27. So now I could look at, maybe these ones that have 4 of them. That's the most that this person in question that we suspect of doing something bad, who he's doing most of his conversations with. But remember, this is the kind of the testing tiny file that we've run this against. So I'm going to run it against the larger file. But before I do, what I want to do is format this a little bit nicer. What I want to do is I actually want to have the key value first and the email address second. And I do this by using this Python code in the next cell here. And I take our dictionary that we just ran and I set it to a variable called counts. So remember, this is really now the counts is really a dictionary. And I take all the keys in that dictionary and I put them in a list, set that equal to another variable called LST, okay? And list is an object in Python that has a method called sort, which obviously sorts all my keys. And then what I do is for each key in that list, I simply print the key value, which is in my counts key, and then I also print the value of the key itself. So let me run that, and I will just show you. This is now my output, and I get that, okay, there were 5 communications to this person. Does that look legitimate? If it does, fine. If it's not, maybe that's what I want to talk to my investigations department about. But you can clearly see that this output is quite a bit nicer than this output in terms of what I'm looking for. And it took really these steps, these few 4 or 5 statements in a list to make that happen. I know that I went over that rather quickly. So again, don't worry if you're not following it, but you have this code and my GitHub public site to go back to and bring it up in Binder anytime that you'd like to relook at it or study it or analyze it and Google some of the aspects that I have in this particular code. So finally, what I'm going to do is I've combined all this code together in this particular cell, meaning that I have my dictionary, I have my loop, I process all my lines with regular expressions, I print the total amount, then I use my list, and I print the keys and key values in a much nicer way. But now I'm going to run this on the full, big, large data set. And again, if you can scroll down and run this in Binder, you should be live and able to do this. And here's my output. I have, as I expected, these 1,797 email addresses. I have the count of here, this person was corresponding 110 times with A. Aarons Z at vermont.edu. I can scroll down this and take a look at it. A number of very large players. Here's 161 at MMA at india.edu. It might be legitimate or it might not. Here's an email address that we saw before with 195 of them. So, you know, again, give me a perspective of who this person was communicating with and who I might want to analyze if it looks suspicious or, you know, questionable. So that is primarily what I was going to cover from a Python workshop perspective. I do want to go back and just talk a little bit about possible next steps. And before I do that, though, I want to stop and take questions, Michael, if there are any.
There is one question related to your code, just came in a second ago. With respect to line 6, what does that do in the code, if you don't mind bringing that up? I know that's a very specific question, but. Sure.
So let's see. Unfortunately, I don't have this in Atom, so I don't necessarily see line numbers, but it is kind of have to guess here at what the person is talking about when they say line 6.
Yeah, I was thinking the same thing.
Yeah. So I don't know that I'm going to be able to answer that easily. I mean, when I go to, let's see, maybe let me assume that they're looking at ignoring comments. It would be 1, 2, 3, 4, 5, 6. So, you know, I'm guessing it's not this R strip line that they're questioning. But in lieu of having this be truly interactive, where you could ask me the question directly and I could, you know, be able to respond, what I will say is, if you're questioning what a line is doing, there are 2 things that you should try. The first is just comment the line out. Right. Now, when I run this, it's as if that line is gone. So you may see what the line does by removing the line.
Okay, I see what they're asking. I'm sorry. If you go 2 lines down from where you are, 3 lines down from where you are,
Okay.
In the for loop there, it says email underscore address equals line 6, colon.
Okay.
So they were asking specifically about that. That's my fault. I
Okay,
could have read that a
got
little
it.
clearer.
Okay, so that's actually a very good question. I skipped over that because I was kind of trying to explain quickly and at a high level. But so what I've done here is I've done my regular expressions on a string called line, and I'm bringing something back that starts with the capital F in from, and then everything between it until it hits a space. And so what I've noticed is that I really need to go where I have the word from. I really need to count in 6 spaces to start at the email address. And so this is just taking this string that I pulled out of my regular expression search, and it's pushed it forward 6 positions so that I start with the email address itself. So in other words, instead of, I'll show you what I mean. Instead of having this from in front of it, what I've got as output instead is the actual email address itself. This doesn't say from cwen.iupui.edu. It just has the email address itself. And this line of code that this 6 positions in is saying, take the string that you found, which starts at the from and ends at the space delimiter, and move past the from and take me to the beginning of the email address and assign that to the email address. And then
They definitely got it. Yeah, absolutely. A little bit of sneaky housekeeping is what you did there.
Very good. Okay. Right. So I will finish off here by just saying, there are a lot of ways to take it to the next level. You could take classes, in informatics at Seton Hall or any other university, classes on Python, classes on other programming languages, classes on tools to use in, managing data. They don't have to be professional software tools, although the Python and other tools like it have the ability to go to the deepest level around usually what you're trying to do, especially if it's a lot of customization. You can look into cybersecurity certificates, similar to the one that Seton Hall offers here. And finally, I would encourage you to learn through doing. Download Python and, try working with it. Do a search through some of the public GitHub sites for other tools that you can use with Python and learn from. Other languages as well. And, start to try to get beyond creating toys and look at real world problems when you've got enough experience behind you in terms of creating a couple of toy-ish like applications. So I will stop there. I have been asked to make sure that you all try to please stick around after the session for the networking in the Wacova app. And I will ask if there's any final questions on the chat. I'm happy to entertain them.
Nothing right now that I see. We'll give them a second, see in case anyone has any other questions. They're very appreciative that you did clear up the line 6 question. That was stumping a couple of them.
Okay.
Otherwise, I'm seeing lots of applause pop up. They can use their little emoticons and emojis to pop up applause. A couple of thank yous have popped in, but I think that might be it. Let's give another 10 seconds or so for people to pop in. Otherwise, I will repeat your call to send them out to the Whova app for networking. That would be fantastic. You got a weird little fist bump looking thing that just popped in too. So I think everybody is pleased with the session, and I don't believe that there are any questions.
All right. Well, very good. Thanks for your help, Michael.
Oh, no worries. No worries. Thank you, everybody in attendance today. Obviously, if you can stick around for the networking session, I'm sure you can speak to a number of our presenters today and talk amongst yourselves about the exciting world of cybersecurity.